Hey everyone, today's Educated video, I want to just give you a little bit of a review for our test tomorrow, but before I do, I just wanted to apologize for not being here today. I hope this video still helps you prepare for the test and gives you an idea of what's going to be on the exam tomorrow. So I've posted a review packet in iTunes U. So just go ahead and go to iTunes U and go to week 27, day 4, and you'll see test 3 review packet. Go ahead and open up that review packet, maybe in a separate window, so that way you can read and follow along, because I'll be actually reading directly off of that review packet as we go. So go ahead, open up that review packet now. Now, what you'll notice at the top of your review packet are just 4 items that I call test logistics. I've got them listed here. And the test logistics say, number 1, you will begin your test as soon as you arrive. So the earlier you get here, the better. So there's not going to be a bell ringer that day. You can see on point number 2, no bell ringer. So get here as early as you can, and as soon as you get to class, you'll be able to begin your test. And the test has 22 questions. These 22 questions, some of them have multiple parts, some of them are multiple choice, most of them are short answer, but there are 22 questions. I think the majority of them you'll feel are pretty straightforward. There's only going to be like really 1 or 2 very challenging problems. And make sure that you guys know some good jokes. That'll be very, very important for the class. Make sure you know a really, really funny joke. And then number 4, it will be graded out of 100 points. So I'll put the how many points each question's worth at the beginning of the question, so that way you'll know how important it is that you answer that question on the exam. So go ahead and take a look at number 1. So the first thing that I expect you to know, you need to understand that polynomials, so I'm reading directly off the review packet, so look at the review packet. You need to understand that polynomials are closed under addition, subtraction, and multiplication, but not under division. What that means is, and you can write these notes under number 1, which let me use a different color here, so under number 1, so what does it mean for polynomials to be closed under certain operations? Here's just an example. So if you have a polynomial, I'm just going to write the word polynomial, and let's say that you add it to another polynomial, a different polynomial, and if you get a polynomial out, then I would say that this process is closed. So this is a closed process under addition. So if you have a polynomial, you add it to a polynomial, and you get a polynomial out, then we would say that this is closed under addition. Now, so closed under addition. That's just an example, closed under addition. Now, if I didn't get a polynomial out, if I had a polynomial and I added it to a polynomial, but I didn't get a polynomial out, then I would say that that is not closed under addition. So really what you need to know is that polynomials are closed under addition, they're closed under subtraction, and they're closed under multiplication, but they're not closed under division. And I made that note on point number 1. The second thing that I expect you to know, number 2, I expect you to be able to add, subtract, and multiply polynomials. So let's look at an example. A very simple example. We're going to look at 2 binomials. So I may give you x squared minus 3, and I'll say subtract x plus 6. Okay? Now, I expect you to be able to do this with any order of polynomials. So this could be a polynomial with 4 terms. This could be a polynomial with 5 terms. I expect you to be able to add these. I expect you to be able to multiply these. I expect you to be able to subtract these. All of those basic operations I expect you to be able to do with polynomials. So let me just point this out. This is a good example because I see a lot of mistakes here. I'm going to start by just rewriting my first term without the parentheses. So I'll do x squared minus 3. Now this is where I see the mistake. Look, we are subtracting this entire binomial. So it's not going to be just minus x plus 6. It's going to be minus x minus 6, we need to distribute that negative to both terms inside my second binomial. So we do minus x and then minus 6. And at this point, you're not done yet. You still need to combine like terms to finish your answer. So I write my variable with the highest exponent first. We do x squared, then minus x. I see like terms, and I do negative 3 minus 6. That's going to be negative 9. So negative 9, and that is my final answer. Okay, so I expect you to be able to do this. Any kind of operation, adding, subtracting, or multiplying with binomials. Now, number 3 says you should know how to identify and classify different polynomials. That is, monomials, constants, binomials, trinomials. This is a lot like one of your homework assignments that I gave you. So basically what this means is if I give you anything, any expression, you should be able to tell me if it's a monomial, a binomial, a trinomial, a polynomial, or a constant. So let's look at an example. So an example of this would be x squared. And I would have a blank here, and I would say, is this a monomial, a binomial, a polynomial, a trinomial? So what do you think? What do you think this is? A monomial, a binomial, or anything else? So hopefully you were able to say that this is a monomial. Now remember, in this class, okay, now these definitions change from class to class and from textbook to textbook, but we define a monomial as a polynomial with one term. So not only is this a monomial, but it is also a polynomial. So I put M and P here. So it's a monomial, which is a polynomial with one term. Okay, so x squared is a monomial and a polynomial. Now let's look at the example, maybe x squared. We'll do 3x squared minus 4. So in this case, we've got two terms here. We've got two terms, so it's like a bicycle that has two wheels. So we've got two terms here, so we would say that this is a binomial. And a binomial is just a polynomial with two terms. So I'd say this is a binomial, so I'd put a B here. And I'd say that it's also a polynomial, so I'd put a P. So if you just look over the worksheet, the homework that has the problems like this, you'll be perfectly fine on the exam. So let's go on to number 4. Number 4 says you need to know how to work with negative exponents and how to find the limitations on a variable when the variable is in the denominator of the fraction. So what does that mean? Let's look at, I'll put number 4 on the next slide. So what I mean by negative exponents, that means if I give you x to the negative 1, you should know that that is the same as 1 over x. And if I were to give you the expression x to the negative 2, you should know that that's the same as 1 over x squared. So basically what these negative exponents are telling you is telling you how many times to divide by that variable or the number that has the negative exponent. So what does that mean? If this is telling you x to the negative 2, that's telling you to divide by x 2 times. Because remember, 1 over x squared, that's the same as 1 over x, because x squared is x times x. So if we have x to the negative 2, then we divide by x 2 times. So 1 divided by x, 1 divided by x. So the key takeaway is that even though these are negative exponents, you still treat them just like they're any other exponent. So if you had x to the negative 2 times x to the negative 2, okay, you know when we're multiplying two variables, let me get rid of that, so we're multiplying two variables here, you still do the same thing. We know that we need to add the exponents. So if I multiply these two, negative 2 minus 2, that would be x to the negative 4, because when we add negative 2 to negative 2, we get negative 4. So I expect you to be comfortable using negative exponents, and I also want you to feel comfortable finding limitations on fractions that have variables in the denominator. So if I were to, let's look at another example of finding, so here's an example of what I mean by that. Example of limitations. So if I give you the function 1 over x minus 6, okay, you should be able to tell me if there are any limitations on the variable x, which in this case there are. By this point, you should know that we can never have 0 in the bottom of our fraction. So what would if x were equal to 6, would this not be 0 in the bottom of our fraction? Yeah, it would, because 6 minus 6, that's 0. So we would say that the limitation is that x can never equal 6. So x cannot equal 6, because if it did, then we would get a 0 in the bottom of our fraction, and then this expression would blow up, as they like to say in mathematics. So for point number 4, I expect you to feel comfortable working with negative exponents, and I also expect you to feel comfortable working with fractions that have variables in the denominator. Now, number 5 states, you should know how to expand expressions using the binomial expansion. Now, the number one question that I've been asked when I reviewed this with my first block is, will I give you the binomial expansion or the binomial theorem? And the answer is absolutely yes. You'll have the binomial theorem. You'll also have the n choose k. Those will be given to you on the exam. But I expect you to be able to solve. If I give you, say, a plus b to any power of n, but let's just say a plus b to the 4, I expect you to be able to expand this using the binomial theorem. Now, because we don't have a whole lot of time, I'm not going to walk through an example of that, but there are plenty of examples that I've uploaded into iTunes U. So if you have any questions about how to expand that, make sure that you send me an email and let me know. Now, number 6, you should know how to construct Pascal's triangle up to the nth row. So I should be able to tell you, construct Pascal's triangle up to, say, the 6th row or the 7th row, and you should be able to do that. Now, when you're constructing Pascal's triangle, okay, these are the first 3 numbers that you should draw. Okay, a 1, and a 1, and a 1. Make a little triangle with your 1s. Okay, now the way that you would do this would be up to the 2nd row. This is Pascal's triangle up to the 2nd row. Or you could think about it like this, up to the n equals 0, up to the n equals 1. So really, this is the 2nd row, but if I say the nth row, this would be the n equals 1 row. Okay, so if I tell you to go up to the n equals 6 row, well, let's do a smaller one just to keep it simple. If I say go up to the n equals 4 row, this is what I would expect you to do. I would expect you to know that 1 plus 1 is 2, and then you cap off your n's with 1s. Now we do 1 plus 2, that's 3, and then 2 plus 1, that's 3, and then I cap off my n's with 1s. Okay, so that would be the n, let's keep that in red. That would be n is equal to 2 row. This would be the n is equal to 3 row. And then I would do 1 plus 3, that's 4. We do 3 plus 3, that's 6. We do 3 plus 1, that's 4. And then I cap off my n's with 1s. So I expect you to be able to do this all the way down for any n value. So there are some really good videos. I think I actually posted one in iTunes U from Khan Academy about building Pascal's triangle. So if you're still not sure how I did this, just make sure that you watch that video to study for your exam tomorrow. So now let's look at number 6. Let's look at number 6. Oh, that is the one that we just looked at. We just looked at number 6. So let's look at number 7. So number 7, you should know how to use the binomial theorem to calculate probabilities of independent events. Now, I'll go ahead and tell you, this will be one that you have seen before. I'm going to ask you to use the binomial theorem. Okay, number 7 is going to be 1. This will be 1. Will be 1. Similar to what we did in class. So if you did to what we did in class. So I'm not just going to throw one at you out of left field. It's going to be one that looks very similar to what you've seen in class. It could just be like the one with the family. Instead of 6 kids, I may ask you to calculate the probability of 4 kids. So I'll just change one of the numbers. Okay, so go ahead and go to the next Educated video and continue the review packet.